In this unit, we're going to learn to use the triangle proportionality theorem and its converse. Before we learn about the theorem, there's one really important concept that we need to understand. It's called midsegment of a triangle. Whoops. You all know what a midsegment is. Midsegment is if I have a segment like this and the point right in the middle would be called midpoint, right? And then if I have another segment like that, and if I call that M1, this is midpoint 2. Now if I connect these two lines, that's my midsegment of this shape. So now if I have a triangle, the midpoint is here, here, here. So M1, M2, and M3. And if I just connect the midpoints, as long as I connect the midpoints, now I have M1, M2, M1, M3, M2, M3, three midsegments. So a midsegment of a triangle is the segment that connects the two midpoints of two sides of a triangle. So let's look at this theorem, triangle proportionality theorem. It says if a line parallel to one side of the triangle intersect the other side, then it divides the two sides proportionally. That's very wordy. So let's look at this example here. So it says if TU is parallel to QS, then RT over TQ should equal RU over US. And this concept is pretty intuitive, right? If there's a parallel, I basically cut everything exactly by this parallel line, and this portion over that portion should equal RU over US. So let's see how we use it. In the first example, we have to find the value of x here. So if we know that this is parallel, then by triangle proportionality theorem, CD over DB should equal CE over EA. And if we substitute it with the numbers and variable given, we should have 4 over 8 equals x over 12. And then we can cross multiply. That's how we solve proportions. Cross product property. So 4 times 12 should equal 8 times x. And 4 times 12 is 48. 8x comes down. Now I divide both sides by 8. I should have x equals 6. See, the triangle proportionality theorem really makes a geometry problem such as this one. I don't know what's wrong with my board today. It makes a geometry problem, like this one, easily be converted into an algebra problem, and that can help us solve with various problems. So let's look at this one. We are supposed to find the value of y. These two are parallel. That's what's given, right? So QT, if it's helpful, you can write it out. QT is parallel to RS. That's excellent. And it's a segment, so I need to add the bar on top. So we know PS is 20 and PT is Y. So then by the segment addition postulate, TS, which is this portion, would be 20 minus Y. So now we set it up. PQ over QR is 3 over 9. Oh, I'm sorry. It should be PQ over QR should equal PT over TS. And then we do our substitution. That's 3 over 9 should equal y over 20 minus y. Now we do our cross multiplication. So it's 3 times 20 minus y, which is these two. And then we cross multiply the red ones. So it's 9 times y. If you do your distributive property, you would have 3 times 20 is 60 minus 3 times y should equal 9y. And then if you add 3y on both sides, you should have 12y equals 60, and y comes out to be 5. Okay? So again, it's to figure out where are the parallel lines are, and then figure out the different segments and make sure that you match them up like that. Set up the proportion like what we did here. Set up the proportion, and then the rest of it is all algebra. So finish this follow up, and we have one more theory, which is the converse of it. So it says if a line divides two sides of a triangle proportionally, then it is parallel. So this time we know that RT over TQ equals RU over US. Therefore, we can draw the conclusion TU is parallel to QS. Okay, so it's the same theory, it just goes backwards. We switch the hypothesis with the conclusion. So let's look at the example here. Given the diagram, determine if MN is parallel to this. So we're given these segments. So all we need to do is to set up the proportion, right? Because if these two are parallel, we must find the proportions of each. So let's do that. LM over MG is 56 over 21. And if I simplify it, it's by 7, dividing 7, it's 8 over 3. And then on this side is LN over NH, and that's 48 over 16. And it comes out to be 3 over 1. And because 8 over 3 doesn't equal 3 over 1, therefore MN is not parallel to GH. Okay? So it's exactly the same theorem, but it's just used backwards. And a lot of calculations of proportionality is involved. So finish these checkpoints. They are all fairly similar. It gives you extra practices on proportionality and cross-product property. I apologize. I don't know what's wrong with my board today. It's going wild. So last theorem is called the Midsegment theorem. It says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. Ooh. Parallel makes sense, right? If it's a midsegment, if it's a midpoint, CD over AD should equal 1. CE over EB should equal 1. So we know that these two are parallel. But it's also this, DE is half as long as AB. That is new information. So we said in this triangle, these two are congruent, then DE is parallel to AB, and DE is half as long. The mid-segment is half as long as the third side. So let's see how we use this in the examples. Given this diagram right here, find the length of QS. So from from the marks on the diagram, you know S is the midpoint because this is congruent to this part, and Q is the midpoint, right? So S is the midpoint of RT, Q is the midpoint of RP. So QS is a mid-segment of triangle PRT. Then we use the mid-segment theorem that we know QS should be half as long as PT. If I do my substitution, it's half times 10, which gives me 5. Okay, so it's pretty easy. It's not as convoluted as the proofs that we did earlier in the chapter. All right, guys, have fun with it. I'll see you in class. Bye.